Okay, guys. Hey, guys, I am recording this, so watch what you say. Oh, wait, that's me. Anyway, I wanted to record it for Rachel, Harry, or for you to look back at it at your leisure.
I can't believe you would say something so vile.
Exactly. Then you haven't been in my class very long.
I recorded.
Anyway, so let's talk about area. We've talked about area before, and we, you guys hush. So we've talked about area before, and the area above, below the graph, but above the x-axis is positive, and area below the x-axis is negative, correct? So if we are considering a function, x cubed minus x minus 1, find the space between the curve and the x-axis on the interval from -1 to 2, then what we really need to have is a good sense of this graph. Yes?
So it's just like a definite integral. And then
Correct. Very good. However, we have to make sure that none of it is negative. Does that make sense? I was going to say it whether he said it or not. I promise. So to be honest with you, I'm going to pull up my calculator and get a decent graph for it. Hold, please. Correct. That license was only free for so long. Oh, sorry. Clear x cubed. Is it minus x? Minus x minus 1. Is that it right there? Didn't make any mistakes? Okay. Oh, decent graph. Okay. So, basically, it looks like that right there. Okay. So I just drew it, just looking at my graph on my calculator. And I want to find the area from -1 to +2. Right? So when I do that, this, if I integrate to find that area, and so far that's our only way of finding the area, then I have to consider that this is going to end up being negative and this ends up being positive. But this is not asking to find, this relates to what you asked earlier. We are not being asked to find the value of the integral. We are being asked to find the area or the space between the graph and the x-axis from -1 to 2. And so we need to find this area and make it positive, right? And then find this area and add it to it, right? Okay, so where does this, so I need some values here. The main value is where it does what? Where it changes or where it crosses the x-axis. Now, I might be able to solve it using algebra. This one, it doesn't look like I can do that. Like, can I factor this bad boy? No. If I set it equal to 0, still doesn't really do me any good, right? So this would probably be on a calculator test. And I would just do second calc. Find the 0 between there-ish and there ish, and 1.3247. Okay, what do we do with that? Yes.
Are we ever going to be like given this like on a non-calculator section thing, and we're like do the
If you had this on a non-calculator test, then we would, let me move that down. If we had this on a non-calculator test, this would be something that you could factor. Like once you set it equals to 0, you could factor and solve for that 0. But this one, you just can't. And moreover, for this problem, I just wanted you to see like mathematically what we're going to do. I'm actually going to do the integral using my calculator. Ethan?
So like, if you do like an integral plus integral, so you
Right.
get like
Correct.
1 to 20%.
I am literally going to do an integral plus an integral.
And you just make the first one positive.
Correct. I know that this area from negative 1 to 1.3247, I don't know, handful of digits until it like drops off. The next digit is 1, right? Y'all good with that? Like I don't really have a hard and fast rule for that. I just, But I know that that integral will be negative because the area is below the x-axis. So I'm going to put a negative in front of it, which will make it positive. Actually, you could do an absolute value. That is a load of work on your graphing calculator, but you could. Then I'm going to do the integral from 1.3247 to 2, and it is a positive area, so I don't need to do that. Does that make sense? Okay, so what have I left out? It's the function dx and the function dx, right? And so we're going to whoop that right there. Now, do you know how to put this on your graphing calculator? So here's what I'm going to do. First, I'm going to put negative. Then I'm going to do I'm going to do alpha f2. And there is an integral. Fantastic. See, even I forget that. Oh, wait. I just, negative 1. If you hit your right arrow, it goes to that top number. Alpha F2. Alpha window. Sorry. 7. And then I'm going to put X cubed. Yes. Oh. Delete. Arrow. No. Delete. Arrow. Minus X minus 1. Ugh. And you have to tell it dx. Then you can do plus alpha window integral. Yes, I put a negative before I hit alpha window.
You might want to do it.
Not the worst idea in the world. But you don't have to. That's a... I used to be kind of a parentheses junkie. Kind of. And then I started like, okay, do I really need it? Do I really need to? Am I doing the most? Or whatever. Holy mother. And now I am...
That's a good number.
Mm-hmm. Does it look reasonable? Can you tell the area is not going to be 57? right. It's probably going to be a pretty small number. We're talking about a very small part of this graph. So this would be about 3.61 units squared. Yes. I don't know the units, so units squared. And actually, IB is kind of nice this way. Like, they're not going to, if you just left that off, it's actually not that big a deal.
It is a big deal.
Now, when I'm doing a physics or a chemistry problem, I'm not going to lie to you. I am like the units Nazi so that I know what to do. Does anybody use the units to actually know what they're trying to do with an equation or something? I do. It's most of the time it helped me. But anyway, I digress. You know what? I wanted you to see this way of splitting up integrals. But I'm curious about what John said. If I do the integral from -1 to 2 of the absolute value of x cubed
Well, it makes the negative value positive. It's quadratic and you like made it all above the line.
Is anybody a little bit nervous about this? Are you?
Oh,
By the way, did you notice a little hesitation just then? Right? That was a lot for the calculator to do, but that is the same thing. Why am I off just the, I don't even know what place that is, the millionths place? Why is it off?
because that's not exactly that zero value.
So which one is actually more accurate? Right, the second one would be, because I rounded for when I divided it up into two integrals. So the answer is yes, I could have done from -1. Hold on. I could have done from, let me get my calculator out of the way. -1 to 2 of the absolute value of x cubed minus x minus 1. So, why would I need to split it up? Like, if I could always do this, why would I need to split it up? No.
You wouldn't. Absolute value is cool.
Say again? If you didn't have a calculator. So if this was solvable for the x intercept, then it is possible this could be on a non-calculator portion of the test, in which you need a decent idea of how to draw a basic, cubic quartic graph, and, solve for that x-intercept, a decent idea of what's negative and what's positive, and then split it up. So yes, there are two different ways to do this, and they both equal pretty much the same thing. So you've got options, is what I'm trying to say. Okay. Let's see. What are my options on this one? I have forgotten what this problem entails.
Oh my god.
Well, you know what I'm going to do?
A lot of numbers.
I'm going to graph that bad boy. Let's see. X cubed minus 4x squared plus x plus 6. Boom diggity.
Well,
Oh, wait a second.
is that an actual number?
Is it crossing at
That's
-1?
-1.
Let me do this. Huh. That looks about as convincing as it can get, right? Like that it's actually crossing at -1, 2, and 3. Okay. So, there we go. Meow. I just drew it. Let me pull that. So, 2, 3, -1. By the way, if I'm not convinced, how could I double check that it's actually crossing through those? Oh, I love you people. Thank you, synthetic division. I love synthetic division. You know what? Earlier, Oliver, you had your hand up and then you put it down when I answered something of somebody else's. Did I answer your question? Is there anything you'd like to ask me, Oliver? Okay, you let me know. Anyway. All right. A little bit strange today. Anyway, I know that, and when it says space between the curve and the x-axis, it means this plus the positive of this. Yeah, I could.
You have to find the
Right.
zeros first.
Correct. I would do, so without a calculator, I would definitely do -1 to 2 of x cubed minus 4x squared plus x plus 6. Oh, that's not a 6. And then I would do what? Plus negative or minus from 2 to 3 of the same function. Now, this is a polynomial. So if you had to do this by hand, is that any big deal? No, you do 3x to the 4th divided by 4, -4x cubed divided by 3, plus x squared divided by 2, plus 6x. That's probably the only one where you're going, wait, what do I do with that one? But yes, that will give you the area by hand. And again, I could do, with a calculator, I could do the integral from -1 to 3 of the absolute value of this bad boy. Does that make sense? Yeah, that. So both of those would get you the area in between the x-axis and that curve. Okay? All right. Now we're taking this up a level because we've kind of done that before, right? Back in May. So now I'm stepping it up a notch. So if you haven't, Matthew, been paying attention, then there you go. Sartell, Tyson. If you haven't been paying attention, this is where you want to tune in because this is where a lot of people are like, wait, I don't get it. Okay, so let's say I have a function, and you know what? I'm going to do this. Let's say we have two functions. We have two curves, okay? And this one I'm going to call f of x, and this one I'm going to call g of x, okay? And no, I literally just did scribbles. Y'all get that, right? But clearly one function is above the other function. And also, I want to find the area from A to B. Okay? Don't know what those values are or whatever. I want to find the area between two curves. This is the next biggest idea and application of area, is the area between two curves. Okay? So this is a biggie.
Find the area under the top one, and then subtract you get the area under the curve of the bottom one from the x-axis and subtract that.
It's as easy as this. You do the integral from A to B of f of x minus g of x. The top minus the bottom. And it is, and I'm going to write top minus bottom. Now, is anybody having trouble seeing how that would be? So, if I just do the integral of f of x, what that will give me is, well, no, that goes all the way to the x-axis. Sorry, I was letting so it would be that, right? Okay. If I do the integral of g of x, it will give me this, which is negative. Do y'all care if I put a little negative there? And this, which is positive area. So the difference between those would be the area, and I'm going to outline it like you need to know whether it intersects or not. Again, if it's like factorable and it's polynomial, no big deal or whatever, then you can pretty much figure that out yourself. If it is a logarithmic graph or whatever, then no, you would graph that bad boy on your graphing calculator. Now, I want you to see that this will give us just the area between the curves, because we'll have the pink, and then minus the negative of this guy, which adds the, that value. And then we're taking away the overlap. Does that make sense? It is as simple as subtracting those two functions and then taking the integral to find the area between the two curves, which is kind of nice, right? Like that makes total sense, right? And so when you're doing an area between two curves, the nice part is I don't give a crap where any of this crosses the x-axis. I don't care that this one is crossing the x-axis here at all, because the minusing takes care of it. Does that make sense? And that is the beauty of finding the area between two curves. Now, the only issue here is that you've got to do top minus the bottom. And that becomes an issue if they intersect in that area. Correct. So, and I'm going to try to draw this very carefully. If I have f of x, and it is, I'm just going to draw, whatever.
No sideways.
That's No, I was going for a polynomial, but it's not the best. Okay. So, but that is f of x, and this is g of x. Okay? And I want to find the area between those two curves. I may or may not be given like here, I really needed to know, like, how far did you want me to go with the area from A to B? But here I might not be given those numbers. I would need to find where they do what? Where these intersections are. I'm going to call this x value A, and this x value B, and this x value C. Are y'all okay with that? Okay. So now, for the love of all that is holy, right? Let's divide this up. To find that area between the two curves, I need to do the integral from A to C. I called that one C. Okay, so you check, right, adjust yours if you need to. Of what minus what?
G of x minus f.
Right. In that area, g of x is on top and f of x is on the bottom. And like we did before, we need to do top minus bottom. That is the big idea here. So I have to do that and then add it to the integral of c to b of f of x minus g of x. Aiden, what were you going to ask?
I'm confused on the first part where you see. I'm confused by.
Right.
Or no,
From
not
here
like
to-
A C. Why are you subtracting them? Because they don't
Because I want this whole area between the two curves. If I do g of x, then I get this top area. And if I do f of x, I will have a negative area because that's below the x-axis. So if I minus, then it would be this altogether.
I think I was just thinking of it as like the
Right, but think of it like this. I'm doing this. Where if I do top minus bottom, then you're good. You're good to go.
That's why.
Yes.
If we have like a trigonometric function where they give us like a region, because then that has like
Correct.
Has like an infinite amount of
Correct. And I have had to check before. I'm like, well, I know this is a cubic, so I know I'm not going to have any other critical points, right? And I don't know what this function is. Whatever it was, I'd have to think, does this repeat forever? Or will it somehow intersect with this guy down here? Or what? You do have to keep that in mind. And that is why this is kind of like the plumped up version of just finding the area. Okay? That's a good observation.
Well, yeah, are they going to ever make this like one-inch graph?
You know what? I think, did I do this next one without a calculator? Actually, I did. So, in the 10 minutes we have left, this is going to be a 2-day lesson. I'll fess up to that. Because this is all with respect to.
Oh my gosh.
Do you know what I'm about to say? To the x values, like the beginning of the interval and the end of the interval. What I'm not going to get to today, which I will get to on Thursday, is that some things you have to, or they're easier to, integrate with respect to y. No worries. Okay, with respect to x, we do top minus bottom. With respect to y, what do you think we do? Right minus left. Very good. Very good. See, it's all going to be, once you get this down, it's going to be more intuitive. And by the way, okay, you know what? I dare you. Y equals x cubed. If you recall, that basically looks like this. Right? Although this is not thank you, but it is not the most ideal graph because I know that x cubed goes through 1, 1 and -1, -1. But, you know, whatever. Okay, now I know that if I factor this quadratic, and by the way, what shape is this going to be? A parabola, and it's going to be opening up. Very good. And if I factor out an x, I know that it's going to cross through 0 and 1. So it's going to look like this. Oh, no. Oh, do those? They don't. They do not intersect. Okay, and you're like, well, Miss White, your drawing intersects. Okay, well, my drawing sucks. Okay? But the reason I know this is like, do the values at 1. This is 1, that would be 0. Do the values at 2. That would be 8. This would be 2. Right? So this is below the quadratic is below the cubic over here. So like you said, Annabelle was like, that's a beautiful graph. Not really.
I just like the way it.
Thanks. Yeah. I get it. It does intersect at the origin, for sure. And by the way, I am given an interval, a beginning interval and an ending interval. Now, I needed to make sure they didn't intersect in between those. But, yeah. So, by hand, if I do top, now this is where you have to be careful, top minus the bottom, and I can go from 0 to 1 because I ain't got no interruptions there. But I do have to keep in mind my signs here. So that's actually going to be x cubed minus x squared plus x, right? So when I integrate, it'll be x to the 4th over 4 minus x cubed over 3 plus x squared over 2. And I need to evaluate that from 0 to 1. And correct, the plus c would cancel out when we do our next step. So that is why I left it out. So this is going to be 1/4, and I'm going to use parentheses, 1/4 minus 1/3 plus 1/2 minus, Who loves the numbers 1 and 0? Right? 0 is your friend. Now, 1/4 minus 1/3 plus 1. Oh gosh, this would be the hardest part of this problem, would it not?
Oh, wait. 0 times.
What's 0 minus 0?
Well, yeah, for that one.
Does anybody know what that's going to equal?
Wait, hold on.
Wait, let me.
Oh,
Wait.
I'm doing the.
12.
Wait, 3 12.
Oh, you're right. Yes, I actually made a mistake. I was at minus and negative. 5/12. It's actually going to be 5/12. The area of the space in between curve 1 and curve 2, or whatever. Nice. Okay, real quick, what I want to show you. Okay, so this is a 2-day assignment, and it is on Delta Math. But what you're going to want to do is, you know what, let me show you your view. Oh my God, y'all graduate this year, don't you? You guys, these are graphed for you, by the way. Okay? These are graphed for you to get perspective of what you're trying to find the area of, and you're given the equations. This first skill, I'm going to pretty much bet my butt that that's from -1 to 1, right? This second skill, ooh, I need to find where they intersect. It's okay, you have this. I bet set them equal to each other and you'll have a simple quadratic to solve. You know, not a huge deal. Then this third section, again, that's pretty, it's not bad, it's top minus bottom. Let me show you what gross looks like. Okay, don't do the last skill before Thursday. You'll drive yourself nuts, okay? That's when I need to talk to you about the...
Oh my gosh.
Actually, wait, that could have been done.
Yes,
Wait,
so
yeah.
bad.
Hold on. I want to show you... Well, it'll go back to the same one. Anyway.
That's really cool. Hey man, it's an A now. In this year, 92.5.
Oh.
Hold on. Wait. You know what? I beg your pardon. I'm splitting this up. You can do all of these. And I'm going to do the y-axis separately. That's it. Sorry, I made this assignment like last week and I forgot. So you're all good for area between two curves. Okay. Stop the recording.